from Poland. Since you are here, I suppose the heavy introduction of the HPC topic is not really necessary. Because today we are not going to talk about HPC systems as such, about access policies, about how to get access to HPC systems, what are the rules, and such. Today we are going to talk about the results of our work, of the work of the National Competence Centers for High-Performance Computing throughout Europe. You are going to see the results as a real-life use cases where HPC really helped enterprises and SMEs in their everyday life and in their business. So why should you even turn to HPC solutions or to the HPC domain? Because the question is relevant because supercomputing has been for some time on the scene, and it is still a very niche domain. So why should you even turn to it? So historically, HPC helped larger corporations and even smaller companies, basically numerical simulations. This pertains mainly to multiphysics simulations, where you simulate physical processes or multiple effects in various systems or processes. So how can HPC be useful here? First of all, it allows you to simulate processes and systems that are either too large, too tiny, too fleeting, too dangerous, or there is any kind of problem of using a real-life physical experimental setup. You can this way gain a deeper understanding of very complex systems and processes. You can predict failures, control the quality of your products, and HPC is then your tool to save money, time, personal efforts, energy, what you can think of. So this has been for a very long time main domain for HPC in private sector. However, in recent months or in recent time, AI has made a very big impact on HPC segment, especially the boom of generative AI. And now larger corporations and even smaller companies are trying to make use of their data that they have and to develop their own AI models, either as a part of their process or as a product meant for their clients. This brings us to who we are and what is our mission. So the National Competence Centers for HPC are main contact points for all issues related to HPC in each country in Europe. We currently have 33 plus 2 National Competence Centers throughout Europe. And you can turn to any of them if you have any question about access to HPC, about transferring your workloads, basically about anything that is HPC related. For example, in Slovakia, what we offer is free project collaboration on R&D projects within open science concept. We offer our expertise and information about how to access our systems. We facilitate also access to our national HPC system called Devana, and basically we help you with migrating your workloads to high-performance computing platforms. We also offer free training events for everyone, for public, so feel free to check out our trainings and join us and gain new competencies and new inspiration. I would like to again, thank you for joining us today. Enjoy this webinar. And in case you are inspired, which I hope you will be, please don't hesitate to get in touch with us. We will post links and contact information in the chat during the meeting. So thank you again and enjoy.
Thank you, Lucia, for your insights. And now let's dive into some real-world application of HPC. Our next speaker, Michal Pitoniak, is from the Slovak National Supercomputing Center. He has been a pivotal figure in the HPC field over 20 years. He was part of the team for Slovakia's first supercomputer Aura, and since 2023, he has been at the National Supercomputing Center working on pilot projects within the NCC Slovakia. So, Michal, please, it is yours.
Okay, thank you, Božidara.
Maybe, sorry, once again, I would like to ask all participants to turn off their microphones.
Okay. Can everybody hear me and see my slide I'm sharing?
Yes. Yeah, now it's visible.
Okay. Thank you very much. So let me go through a few use cases we selected for today that we hopefully successfully helped our SME partners to carry it out. And let me start with the engineering application. Although I'm not a CFD expert, CFD means computational fluid dynamics, and there are better experts present, like the Dr. Karasek, the next speaker. So we were contacted by a company called Shark Aero to help them increase the efficiency of their workflow. And what they do is they design and manufacture ultralight sport aircraft with two-seat tandem cockpit. So they already knew basically how to do the simulations, but they were too slow, and they basically were not efficient enough to allow them to investigate all possible changes and modifications they were interested in while designing their aircraft. So let me scroll a little bit here. So basically, the workflow consists of creation of so-called mesh, which is like a grid of points on which the desired properties are calculated. The mesh has to be segmented, and the model has to be included in the CFD simulation software. In their case, it was OpenFOAM. In our case, it was SimpleFOAM. So slightly simpler program for this purpose. So basically, they were using a desktop computer, and the simulations took really too long. So first thing they could do is to migrate their workflow to our HPC system, but without any modification to the software stack. This didn't bring only like marginal improvement, let's say 50% or so. So we tried to substitute the software components in the workflow for softwares that can utilize HPC platforms, so they can parallelize to multiple cores within the compute nodes. And basically, we got efficient parallelization, which you can see on these two graphs. One is related to the generation of the computational grid, which was done by the Snappy Hex Mesh software, which scales fairly well compared to the ideal scaling, the green curve. But the scaling of the CFD calculation itself was quite different from ideal. So we got some nice improvement to 4 cores, then some improvement to 8 cores, and then the performance started to deviate. But this is a kind of a multi-dimensional problem, which is related to the size of the mesh and the size of the problem itself. So basically, for fairly small problems, you cannot expect perfect scaling or scaling to larger number of cores. But still, at the end, after migrating and doing all the software work, we end up with a 8-time speed up compared to their deployment on the desktop on HPC system. This is one aspect, but the second aspect is that they could run multiple simulations in parallel, like hundreds of simulations of parallel with different starting parameters, different setup. So basically, they could solve the problem much faster. As with the rest of the use cases I will be showing today, you can find detailed report in English and in Slovak on our website, which is you have a QR code here, but you can easily find it. So let me switch to the second use case, which is slightly different, and it's from the AI world. And this was a cooperation with basically company Dogsbed and also their software provider, Codium. And there are companies developing betting and iGaming platforms. And their desire was to both enhance customer engagement and prevent the gambling kind of habits or gambling behavior of the players. So we designed a transformer-based autoencoder, which is a specific kind of a neural network topology, a kind of a simplified version of those used in the large language models now, so popular. And with cooperation with Codium, we designed 19 features, which were like a time series of certain features, like login frequency, cash deposits, withdrawals, and so on. So some of the features were were modified by a sliding window, and certain other transformations you can again read about in the detailed report. And what the autoencoder does, it basically tries to on its output, it tries to reproduce its input. And if the input and the predicted output disagree, you basically get a reconstruction error, which you can correlate with the anomaly score, or basically with the gambling habits of the players. Maybe thanks with with a little help with some proxy indicators. And this was a very successful application, and particularly in the HPC environment, because they had really like huge amounts of data, like tens of gigabytes of data, and the network topology was also quite complicated with close to 1 million parameters. So this certainly was a case which they couldn't train, optimize, or develop on their premises. So, and another nice feature is that once you have the model trained, it's pretty easy in terms of computing power you need if you want to deploy it and use it for inference in a real-time scenario. So at the end, we hopefully help them help the betting and online casino providers to mitigate the negative consequences for players, which is in line with the European trend in risk management. And now they are able to track the gambling patterns or gambling habits in real time using AI trained on HPC system. Another case is also from AI field, which is sort of a typical nowadays in HPC world. And particularly we in Slovakia, we were not lucky yet to have too many like engineering customers, but hopefully this will improve in the future. So this case was in cooperation with the SME called Nettle AI, which is a company who's focused on developing like AI-driven conversation platforms, chatbots, and stuff like that. And their task was to basically develop or improve the named entity recognition module used in speech-to-text transcription from data they have from the chatbots. So basically, at the end, this is supposed to be kind of a service for institutions like banks and insurance companies and stuff. They need to update clients' information from time to time, like if they change an address or telephone number or anything like that. And surprisingly, and especially if you deal with the Slovak language, you don't have many, like practically almost none open source large language models that could solve this problem out of the box. So basically we helped to design a kind of a classification, a neural network based on the a large language model called Slovak BERT, which was so basically we took the Slovak BERT and improved it with the classification head and retrained the whole model, which has like 124 millions of trainable parameters. And when you had a sentence, it basically classified all the words in the sentence, and it classified it into a like beginning of the street name, inside of the street name, house number, municipality, so the town or the city name, and the postal code. So if you look at this confusion matrix, which is a representation of how many of these tokens, items, or the model without fine-tuning or without retraining was able to classify, you see that the green numbers on the diagonal represent the correctly classified items, and the red boxes or red cells of diagonal are like misclassifications. So this was the first iteration of the model we were trying to improve. So not even slightly better than the vanilla model, and this is the model we obtained at the after several iterations and improvements. So we still have some misclassifications here, but the overall performance is significantly improved. The overall accuracy is 96%. The trick or the problem with this particular case was that we didn't have too many data, like real life data available from Nettle. So we have to create the synthetic data using the ChatGPT API, which so we designed a kind of a template scheme where we could eventually create like tens of thousands of like artificial sentences that the customers potentially would answer the voice bot or the chat bot, and this is what we used for training the model. And maybe I forgot to mention at the beginning that somebody might have a question that why didn't we use the ChatGPT API from the very beginning, and this is and there are several reasons for that. First of all, some customers have problems with the privacy of their data. They didn't want to share the responses or the conversations with the customers, particularly when they are related to some sensitive data. They don't want to share it with the public API. That's one issue. And another issue that you certainly have like lags and delays caused by calling external AI, which can be done much more efficiently if you have it deployed on the premises. And similarly to the case before, training of the model on HPC system was feasible, and inference of the model is computationally easy and can be done by the company on their own hardware. And the last case is the cooperation with the Polymer Institute of Slovak Academy of Sciences. So this is basically an academic use case, but we see that similar cases can arise in the industrial domain or SME domain. So we decided to include this use case as well. And so what the cooperation was about, this particular research group at the Institute of Polymers is kind of synthesizing special biomaterial or these microcapsules that can encapsulate living cells used for treatment of some disease. I'm not sure what it was right now. So the thing was that during the preparation of these macrocapsules, you need to control the quality in the real time. So the thickness of the membrane and the general shape of the microcapsules and so on. And so how they did it before is that they had a microscope with a camera, and they took the picture, and then they had a colleague there who was like manually checking how many of these cells are fine or have the desired shape or other properties, which obviously is very inefficient, time-wise, money-wise, and so on. So we help them to design automated workflow, which consists of processing the shots from the automated camera. Then it goes to first it's the microcapsules. You can see them in the red squares. First, they have to be detected using the YOLO neural network, which is particularly suitable for identifying objects on pictures or on shots. Then we use the UNet, another neural network, which is popular in an image processing field, which helped us to create these so-called binary masks, which basically localize or can copy the shape, outer and inner shape of the microcapsule. And then once we have these binary masks, we can do some post-processing and measure the properties of this elliptic shape, like the axis of the ellipse and several other topological information. So basically what we did was we managed to do a automated detection and measurement of the microcapsules, which replaced often error-prone and money-consuming human activity. And as you can imagine, processing thousands and training neural networks on thousands or tens of thousands of such pictures is also very computational demanding, and HPC environment is once again very suitable for this purpose. So if you're interested in more use cases, you can either find them on the EuroCC access page, which are the collection of the all European or the use cases of all European NCCs, or you can look at our website and find more detailed reports on the use cases I was presenting, and also some more, and some more are coming. Thank you very much for your attention.
Thank you, Michal, for this very informative presentation. So now we have some few minutes for your questions. Let's see in the chat if you have some questions. In the meantime, you can still write your questions down. I have a question for Michal to the third case he presented. Would you maybe tell us more to the benefits of using synthetic data for training the named entity recognition model?
Yes, so this is very this is a situation with which you can encounter very often when dealing with AI problems, that basically you don't have enough training data, or you don't have any enough real-life data, and basically the only thing you can do is to substitute them with the synthetic ones, but you have to do it carefully not to end up with a biased solution, which is possible, but I would say it's a problem dependent, and basically if you try hard enough, you always find a solution.
Thank you. If anyone has some more questions, we still can come back to this in the end in the discussion. And now I will introduce our next speaker, Tomáš Karasek. He is the director of the National Competence Center for High Performance Computing in the Czech Republic and the Parallel Algorithm Research Lab at IT4 Innovations. With experience at the Institute of High Performance Computing in Singapore, he has managed over 30 industrial research projects and authored more than 20 scientific papers. And today he will share examples of using artificial intelligence to solve engineering problems. So please, Tomáš, you can start the presentation.
Thank you very much for the introduction. I believe you could see my slides.
Yes.
Okay, great, because I'm using so many systems that I'm not sure how it works on each particular one. So thank you for the introduction, and today I will be talking about AI in the field, which some people or most of the people are basically not thinking about the AI in this area, because nowadays most of the AI that we are familiar with is ChatGPT or large language models or image processing, as was showed at the previous presentation. But the AI is also used in the engineering as well. And I will show two cases where we combined the numerical modeling and simulation, which is, let's say, the classical user of the HPC, and the new techniques, which is the artificial intelligence. And what is the approach I will show in those two cases, because they are very similar in the way how we use or how we combine the numerical modeling and simulations and AI. So, for example, is from the energy sector. Basically, to create the energy, we still rely on burning something, burning the coal, burning the natural gas. Even when we will go for the burning of the hydrogen in the future, we still will be burning something, or we will burn basically the waste, because it's not allowed to store it otherwise. So we will need to burn something, and from there we will definitely create some pollution. So in energy sector, the pollution is the key restriction when you build the new, or when you modify the existing power plants or heating plants, etc. So basically, the example I'm showing is our in collaboration with the SME Orgres, which is basically developing and selling the components for the power plants or the heating plants, and they are focusing on the part where the exhaust gases are cleaned and where all the pollutants are basically removed from the exhaust gases to meet the requirements of the law and of all the environmental things. So basically, when they enter the bidding competition with the other companies for the operators of those plants, they have to come out with the budget within very restricted period of the time, and there is no space or no room to run the complex numerical simulations to be sure that the proposed solution will work and will be within the budget. So they need a very quick software tool, which could help them to estimate whether the proposed solution for the catalyst section of this component will work or not. So they approach us, and basically we worked on the approach using the numerical modeling and simulation and the AI to develop such a tool. So basically, we are talking about this red part of the whole assembly, and it's the part where the catalysts are, the catalyst layer are placed, and basically the one and only thing which those layers should do, that their functionality is to reduce the NOxes and other pollutants to the required levels. So basically, thanks to those catalysts, you will reduce the NOxes to the admissible amount. And there is several things which must be considered, not only the reduction, but also things like how the profile of the exhaust gases looks like, because what is favorable for you as an operator is when those velocities are uniform, which is this magenta picture down there. If they are looking something like the yellow profile, you will have a problem, because your catalytic layer will be weared on one side much more than on the other side. So basically, you have to replace them sooner, and it's very costly. So basically, what are you trying to achieve is also the uniform velocity profile. So these are two things which they have to consider during the preliminary design of the catalyst layers, and basically what they needed is a very quick solution. So basically, when we discussed with them whether it's feasible, we said, okay, it might be feasible, but we will have to employ the AI, because you never know how the section where you have to put the catalyst layers looks like. So basically, you have so many options, and if your software should be generalized, there is no other way than create some AI-based solution which will be able to give you the prediction how the exhaust gases will looks like before the catalyst layer and after the catalyst layer, and what would be the velocity profile. You also don't have enough measurement data, because nobody is measuring those things, and get all the experimental data could take years. So basically, the only way is to combine some measurements which are available with the use of the computational fluid dynamic simulations. And that was our approach. In this presentation, I will focus on one variant which we started with, but we incorporated all the variants, and we developed the surrogate models for each variant to give the customer required software. So there are some descriptions. So we used the OpenFOAM, which was already mentioned in Michal's presentation. It's a quite powerful tool, and the advantage of using the OpenFOAM is that we are not limited by the licenses, which is the case of the commercial code. What we had to do is the parameterized geometry, because we have to be able to inform the neural network that for this parameters, the output looks like this. So basically, as you can see, we parameterize all the geometry parameters, and we also parameterize the velocity input at etc. etc. All those parameters were set in the CFD simulations, and thousands of CFD simulations were created and run to get the synthetic data for the AI model I will show you later on. There is one picture which shows the uniformity index, which is the index which tells you how the flow is uniform. I was talking about this earlier, and you can see that the uniformity is not sometimes the uniformity is very bad, and you have the high velocity profile at certain point of the output, which you would like to deal with, and you would like to try the combination of some parameters to make this uniformity index equal to 1. And I have some outputs from the neural network, which we created. Another requirement from the company was that they would like to incorporate the AI model into their software, and they wanted basically the formula to program it into their existing code. So to achieve that, we were using the neural network, very simple neural network, consisting maximum of 16 hidden neurons, because if we use more, we won't be able to give them simple formula. And this slide, you can see that with the one hidden neuron, the relative error is significantly higher than if we use the 16 hidden neurons, and basically with using the 16 of them, we have the relative error, which is reasonably small, and basically give us the confidence that this AI-based software will be sufficiently accurate when it comes to the prediction of the real data. And this is basically validation step where we use the prediction for one hidden neuron up to the 16 neurons. So you can see that for one, the network is not trained properly, and that prediction is not that accurate. But coming to the 4 or 16 neurons, the prediction is very accurate. So we are very confident that this neural network we basically trained is capable of predicting very accurately uniformity index. And we did the same for the reduction of the NOxes, reduction of the carbon oxide, and reduction of the sulfides. So we created the comprehensive tool with the company, which gives them very quick estimation how the solution they are proposing is capable of reducing or performing as they wish. So this is one example of using AI in engineering. And the second example is for the transportation, in the transportation area. The company is thinking to modify or to design the new system for weighting of the train cars or trains, because the existing solution, which is the picture is on the right side of the slide, is expensive. The trains must stop on the scale or travel by very limited speed. And when you have the train, which consists of hundreds of cars, it's time consuming and very expensive. So they are thinking to develop the new system, which won't require very expensive equipment, and will allow the train to travel close to the normal speed. And the idea is to use again the neural network and use it to predict the weight of or the mass of each individual train. At the beginning, as input data, there's a signal which comes from the piezoelectric sensors, which basically measures the deflection of the rail, and they are trying to train the neural network to give them the answer how much each individual train weighs. They have the information what is on the train, because the steel pipes or the coals has totally different characteristics, but still you are limited by the data which you measure. There are not enough data to be measured, and all those environmental things like humidity, or whether it's dry season, or whether there was the heavy rain yesterday, etc., will change the measurements. And of course, many parameters, as the ovality of the wheels and other things which cannot be measured will influence the measurement quite substantially. So to train neural networks or some deep learning network using only the measurement data is very difficult, and that's where the numerical modeling and simulations come into the play. We could simulate all those parameters which cannot be measured or which cannot be established, and we can create a synthetic data which will be used to augment the experimental data and to be able to make the prediction much reliable, and the results will be with the higher accuracy. So instead of using only the measurement data, our idea is to use the simulation data as well. And what we did is we created the synthetic data for the training phase, and you can see that during the 100 epochs, we were able to train the neural network, which predicts the true values quite accurately, and that was for the neural network with 70,000 parameters. So synthetic data were created based on the numerical modeling and simulations, and this data were used to train the neural network. And the validation phase, where we created another set of the synthetic data, and we predicted the values using the neural network, and compared with the true values. And you can see that basically the relative error is within the 5%, which is acceptable in the engineering community. And here is how the maximum relative error depends on the number of training samples. So you can see that when you have more than 1,000 training samples, the relative error is quite low and is very acceptable. Another thing which we consider is using so-called physical informed neural networks, and this is something which could even help us to further refine the solution. So instead of using only the neural network, we are also have to fulfill the partial differential equation, which is incorporated into the whole workflow. And we can also predict other parameters, not only the weight of the train, but other parameters as well. But this is ongoing work, and we are looking into the pins as a thing which is state of the art recently, and we are trying to use it for other other cases as well. So this is all from my side, just showing you that the AI could be used not only as a chat GPT or to even to do the image processing or large language models, but the same algorithms and same techniques and same methods could be used in the engineering to solve the real world problems in many areas.
Thank you very much, Tomáš. So, are there any questions from the participants? I don't see any in the chat, but maybe you want to ask directly. In the meantime, I have a question for you, Tomáš. Could you tell us what were the biggest challenges you encountered when integrating AI methods with traditional numerical modeling and simulation techniques?
The most is to get enough computing resources, because for those simulations, it's quite demanding, especially when it comes to the high fidelity CFD simulations. You need a lot of resources, but it pays back when you have the neural network which is trained, or this AI model which is trained, then the optimization, it's much faster. And when you use it for for, let's say, design optimization in the future, it will give you the results much faster than using the classical approaches.
Thank you. Now we can move to our next speaker. He's from Poland. I welcome Szymon Mazurek. He's from the AGH University of Krakow and represents NCC Poland. Szymon is an AI developer with extensive experience in HPC environments and is currently pursuing his PhD studies. He will discuss the SpeakLish initiative, a community-driven effort to advance the Polish national LLM ecosystem. So, Szymon, please, you can start your presentation.
Yeah, thank you for the introduction. Let me just quickly share my screen and let's proceed. So can you see my screen?
Yes,
Please.
Szymon.
Okay, thank you for that information. So let me go into the presentation mode. So today I'm gonna be talking about the SpeakLish initiative. That is generally a very big open source project to create a Polish national large language model that is openly available for the business, for the open source community. This is one of the two biggest AI projects that we run here in Cyfronet. The second is the Meetwin, which is the European founded project. And today I'm gonna talk only about SpeakLish, as this is, as you will see, pretty extensive initiative. So without further ado, yeah, I'm gonna go quickly through the project overview. Then we are going to look more into the pillars of the project. And then we will see also how the HPC component was fed and allowed us to enable those pillars to be developed, to be explored, and also some numeric evaluations on the training of such models, and know-how that we both here in Cyfronet and within the SpeakLish team gathered. So starting with some brief introduction about the project. So this is something purely initiated by the group of volunteers that decided that they will initially create only a very big open data set of text corpora for training Polish language based large language models. They officially started in the end of 2022, but in fact, the first effects were seen in the beginning of 2023. And their initial goal was to have 1 terabyte of Polish text data available for the researchers. They had some initial plans on creating language model, but it was a small 1 billion parameter language model that they tried to train locally. Actually, we started supporting that initiative. We came into a collaboration by the beginning of this year. And yeah, the results are pretty remarkable. So the initial goal of 1 terabyte of Polish data is achieved and surpassed by quite a lot. You will see that in a second. The community also grew a lot. There's more than 350 people involved. And we also have some base open models trained, and basically entire ecosystem of benchmarking, using and evaluating those models got created. So we will see that. We will see that in a second. So the first usage of the HPC resources, and that was a great enabler for the project, for the initiative, was the data collection and the data creation. So you can imagine that scraping the text from all over the internet, even if it's limited to Polish language, is quite an extensive task, requiring a lot of storage resources. And then also the data has to be processed. So the texts are of mixed quality. They also contain some unwanted contents as HTML tags and other contents that are present in the World Wide Web website. So all that cleaning and parsing and even assessing the quality of data had to be done. And basically, this was the first point of collaboration that we established. And with the HPC, the data deduplication and classification into quality categories was enabled. Basically, with the usage of multiple GPUs and CPUs, we were able to shorten that process from initially for 800 gigabytes. It was estimated to take something around 1 month. Finally, we managed to complete that within 4 days, I believe. Not sure with the exact number, but 4 or 5 days. So there was also an artificial neural network created by the Speaklish users involved. We also used XGBoost algorithm to perform that classification, and then we discarded the ANN and fell with the XGBoost algorithm because it was simply more effective and faster. So that was the first part. And here we can see some results of the data gathering. So as you can see, the goal is reached. Currently, the team managed to collect 2.2 terabytes of raw, or maybe not raw, but cleaned and ready to use Polish data that is openly available on the website for the researchers and other institutions, other industrial places to use. So that's quite an achievement. And here we can see also some statistics about how the data gathering process was proceeding, and some statistics about the gathered data sets. So we can see nearly 600 million documents is quite a remarkable number. So the next step, which is basically the core of the project, is the development of the foundational models for Polish language and open sourcing them. Because there's, as probably you are all aware, that there is also very big need for open and language specialized models to use, because not all institutions within a given country can use the available closed source third-party large language models due to privacy reasons, due to some regulations and sensitive data processing, perhaps. So there's a need to have those models on-prem. Therefore, that was after establishing the collaboration with Cyfronet, that was one of our primary goals, to have such a foundational model and give it to community, because it's gonna benefit tremendously all the users interested in such use cases. And therefore, we had several attempts to train such a model in different sizes. We initially started with 7 billion model and a 10 billion version. 7 billion one was better in terms of benchmarks. So that was the version number 1. I'm not gonna spoil because in few months, in few weeks, there's gonna be announcement of the second version, but the 11 billion model that is improved quite drastically is already there, and we see that it's much better than the first one. Therefore, we have actually 3 foundational models that are gonna be or are already openly available. They were based on the Mistral 7 billion model, and the pre-training was continued. From that, we also had some trials to train those models from scratch, but it was actually not leading to any better, even worse results than we discarded this approach totally. And then on the gathered and curated data, we performed a supervised fine-tuning with instructions, and basically we also from time to time, when the new open foundational model is released, we have some trials to continue the pre-training or make some fine-tuning and see how it will perform. We also create a separate tokenizer and tune that for Polish language, so it allowed for a little bit of extension of the context of the model, basically more effective compression of the text. And yeah, continuously we were working on new architectures. And then proceeding to ecosystem benchmarking, as I mentioned, data and models are 2 parts of that. The third pillar of the project is ecosystem of evaluation and usage services that have been created. So first and foremost, continuous benchmarking for Polish language. I'm gonna show you in the next slide, but basically we have created a leaderboard where the different models can be evaluated on Polish language benchmarks and compared between themselves, which one performs better, and also extensive benchmarking of those models was allowed by the usage of HPC resources. There were also new benchmarks specifically for Polish language that were developed and are currently being used there. Several models were evaluated, several dozens. I should have written there because we have benchmarked quite a lot of models. In the upcoming slides, we will also see the empty bench for Polish language created and released that is currently available. And for the model testing, we have internal services for inference and supporting all those benchmarking tools. So first one is the test panel. This is the visualization from the Hugging Face, basically in the Speaklish. In the Speaklish subspace on Hugging Face, you can chat with the model. This is actually pretty simple. Here's the leaderboard. As you can see, to the right, there were multiple more columns there, but basically we have different evaluation data sets that mostly evaluate the ability of the grammatical correctness, reasoning in a given language, and we can see here that this is actually older screenshot, but foreign models are performing quite well, and the top performing models are Quen and Mixtral, and now Meta Llama 3. That perform really well on those benchmarks in Polish language, but this is, as you can see, kind of different category of models because they are huge. They are much bigger than the model that we developed. So they are both 70 and 140 billion parameters. So this is another category of models. Here we also have the Polish empty bench screenshot. So basically there is a LLM as a judge. Currently we use GPT-4 in this case, and there are two models answering a given question. And the meta model is basically judging which one was better and what's the score. And we can see over here that in the 4th place there is a 7 billion version of Bielik, because that's the name of the developed LLM. And before Bielik there are other bigger models. Some of them are closed source as sorry, no, all of them are open source, but are pretty big in comparison. There is also some less known evaluation benchmark called EQ Bench, which measures the emotional intelligence, as we know that robustness of the model in this aspect and truthfulness, emotion, consideration of emotions of the user is also being more and more emphasized within those applications. Therefore, we also created such an adaptation of the EQ benchmark for the Polish language. And finally, our latest release, Chat Arena, where users ask the questions to a model, to randomly selected model answer, and in a blind trial, user does not know which one of the model generated a given response, and they have to decide which one was a winner. And we use ELO ranking metric from chess to rank the models and the results of the evaluation based on the user opinions. And currently, as you can see, GPT-4o is the leader. Right after, and there's a Llama 3.1 with enormous number of parameters, and the fourth place is taken by the not yet publicly released Bielik 2 model with 11 billion parameters. So this is actually something we are very, very proud of, that users mostly choose our model as a winning one in this class of model within a given range of parameter sizes. Here are some benchmarks, so some speed ups observed from the training. As I mentioned in the beginning, the group before starting the collaboration with Cyfronet, they had some trials to train the model themselves on the RTX 4090 GPU, so the local workstation for 1 billion parameters, and it took them 45 days to train such a model on the GH200 GPUs that we internally did our benchmarks on, using 64 of them. It only took 5 hours on the same number of tokens, so the same number of input data. So we can see that in initiatives like that, HPC resources are tremendous enablers, because they first allow you to scale the models into proper parameter sizes, and then train them with a big corpus of data in a reasonable time. And yeah, the future of the project, as I mentioned, the release of the version number 2 of Bielik. We're also starting some work on the multimodal model, and which will also be released and publicly available. And we want to start cooperating with other business that are basically asking for the access to Bielik and want to use this model internally. We also plan to start some knowledge transfer initiatives, because we developed quite a lot of know-how during that project. Therefore, we want to also share that publicly with the community. Yeah, here's the team visiting Cyfronet. In the background, there's a Helios supercomputer here in Cyfronet, and that's all from my side. I'm waiting for your questions if there are any. Thank you.
Thank you, Szymon, for sharing with us your insights on the Speaglish initiative. And before any questions from the participants arise, we have one question for you. How do you ensure the Polish language models developed through Speaglish remain competitive with those from larger global companies?
That's a very good question, and it's hard to answer, because many times when we had that, now we have the great version of the model, there was some new large language model released that in the benchmarks, and even as we've seen in the chat arena, it performed better and users preferred that. But basically, how do we ensure that is that in the given class of models, by class I mean the size of models, we are training our model on a very extensive data set of first raw text, and then curated instructions specifically in Polish language with emphasis on having within the instruction and within the text the cultural context of Poland and other features of the language. And to our knowledge, no other group currently had gathered this much and created this much of a Polish language data. Therefore, as I say, in that given class of models, we cannot guarantee that. But as our tests show, in that range of the model sizes, users usually prefer the answers from Bielik, and it deals with Polish language very, very well, even if in some basic chat application. There is also Plume initiative, which is also big project in Poland to develop a large language model for the Polish language, and they will release their model by the end of the year. So we will see who developed, let's call it so, better model then. But I believe you cannot be sure, as the field is so dynamically developing. So yeah. But it's gonna be let me just add one thing. Actually, it's gonna be beneficial. Well, our end goal is to have good open model for Polish language. Then if not us, but someone delivers such a model, then we are still happy because the problem is solved.
Thank you, Szymon. So if are there any other questions to the use cases? Even with the previous speakers, you can still write your questions or ask directly. If they are not, maybe I would have a question for all speakers relevant for SMEs. So how do you think, in your opinion, can SMEs without prior HPC experience start exploring these technologies, and what resources are available to them? Maybe if you could talk briefly about this topic as well. Tomasz or Szymon.
So I'm gonna try to answer, or rather speculate. That's, I believe, on the side of the excellence centers and the HPC places that we have established accessible knowledge base and provide resources for the users to quickly adapt to such environments and get the know-how necessary for the usage of such resources. It's pretty broad response. I cannot think of anything more detailed right now.
So if it comes to the companies without a prior experience with the HPC, the one and mainly only option is go through the NCCs, because they could help them to start the journey towards the using of the HPC. But resources, basically it's the long journey. So if the SME has no prior use, never used the HPC before, it really depends basically what is their business. So if this is the company who is end user of something and developing the product, and they use the numerical modeling on simulation or AI, it's much easier than the company who is basically new in the digital technologies and never used this before. So for them, the way how to get to the level that they can benefit from the HPC is the long journey, because they have to change their processes first, etc., etc. So it really depends on the company itself, and NCCs could help them to start this journey where the HPC is the final destination.
Thank you, Tomáš. That's also our message we want to convey through this webinar, that the SMEs should contact the National Competence Center to help them with their projects.